Welcome everyone to our newest reimagining session. And happy to be your host today, and welcome our Data Masters team and our speaker today, Oliver Tanevski, who will share more insights on DataOps operations, the processes, ETL versus ELT, and share a demo on Meltano, their tool. Oliver, the stage is yours. Welcome.
Thank you, Gargina. Hello, everyone. I will start presenting right now. So I will share my screen. One, share. So I think we're set. So we can begin. So today I will be presenting about DataOps tool called Meltano, which will help us to create powerful ELT pipelines. So on today's agenda, I will first give a historical overview about how ETL and why ETL first was developed, and later on how this transitioned to the new paradigm called ELT. And I will point out the differences between these two techniques. And after that, I will introduce the Meltano tool, which I will discuss why it is used. And later on, I will present a demo about it and to see how it is performing in action. So in the beginning of the 1940s, basically, everyone started to develop basically the first computers, and they were trying to process little bits of data so it can help out with their daily life. So they were basically doing some simple calculations. Nothing too special, not in the volume that have today. And they started out building as many servers or computers, so to call them, and started building centers. And they use this data center for their data, their calculations, and try to get as much data as possible. And as time progressed, basically a lot more companies that are formed at the time try to get as much data as possible. So we have banks that are basically created. They're storing data. They're storing transactions data about everyone, and they needed some capability in order to transform and analyze this data later on. So in the beginning, on the 1970s, actually in the 70s, the concept of ETL was first formed. So ETL is basically extract, transform, and load. The extract part is where we try to pull some data from some system, either it's a local file or database or API. Then we have the transforming stage where we transform the data, and the load is basically where we want to save this data, either locally again or into some database. And basically in this period, the volume of this data started slowly to grow, and also many other tools were created in order to tackle this problem. As time progresses, the technology also exploded exponentially, and in 1993 we have like the biggest explosion, which is the internet. And basically the internet was made free for use and free for everyone, and this gave us the capability of every single user to create websites today and create a lot of content that later on can be browsed through the internet. And all of the applications and technologies that were developed before this time they didn't have the capability, so to say, uh, to transform this big of a volume of a data. And many other companies started to develop tools to manage this scalability of the data, and try to create uh, as many reliable systems as they can. And at the early 2000s, basically, we getting to know the term of cloud computing, which is firstly uh, mainstreamed later on by AWS, so Amazon Web Services, and it basically took the world by storm with this in terms of the developer world. So everyone started since that time to slowly create applications on the cloud, because it gave them the flexibility to make their to make their apps very reliable, and also to create very powerful systems for analyzing this data as well. And as technology progressed, in the early 2000s, basically the whole AI data science world exploded. So we have creation of the big data, which is structured or functional. And this needed new processing this data, because the ETL, the old process, which is ETL, was basically data or on-premise, which on-premise by I mean in the data centers itself, rather than on the cloud. And that is why a new paradigm started, which is ELT, in order to tackle this problem. So what are the main differences in ELT? So on the ETL side, if we look at the picture, we have like these bubbles, the data, and this data, as we call it, is the raw data. So there is no like filtering here. We get that either from base, first text, and later on we send this raw data to what we call a staging area. So this does this is usually done on some powerful server, or if it's on the cloud, it's done in some virtual machine, uh, very powerful virtual machine, and later on this is transformed. It's sent to what we call a data warehouse. So data warehouse is basically a term for storing processed data. And later on, this processed data can be used for whatever we like, for analysis, for training machine learning models, and also gathering insights from the data as well. Now, if we look the ELT part, on the ELT side, we have the same raw data as this, but we're just moving this data to a destination system. The data that is moved to that destination, it's called basically a data lake. So this is simple movement. We don't do here any transformation, and this gives us at this moment even flexibility analysis on the raw data itself. After after the data is moved and it's in this called data lake, we can use some the services that are in cloud or also locally on premises to transform this data and put it in the data warehouse that can be again used for analysis or training machine learning models. But what is important here is that in the ETL side, when we move this data to data warehouse, we move it as a whole. So basically, we'll need a really powerful computer in the transform section to process this data. Unlike in the ELT part, we can just send this raw data in. So we can send very small chunks of data to the data lake, and we can utilize uh, today the cloud technology, basically, and all of the services that cloud AWS has, the Azure has, and GCP has for processing big volumes of data, which is in fact a lot cheaper than with the ETL process. So the main things, as I pointed previously, they're just summarized on this slide. So the process when we have ETL is data is transformed at staging server. So for example, you have the extraction on one virtual machine, then that data can be moved either on a new machine for transformations, which has to be really powerful, or in the same one. And after that, that transformed data can be put in a data warehouse, either on the same machine, which is usually the case for on-premise, where most of the extract, transform, and load is done on the same machine itself. But this has a cost that this machine will be extremely powerful. And for DLT, this is not the case. Basically, we're doing copy pasting and we utilize, again, if it's on premise and ELT is done on premise, it will roll back basically as same as ETL. If it's done on the cloud, then that transform part can be utilized by some service that is available on the cloud, which can actually process huge amount of data. And with the ELT part as well, by doing these transformations, since it's a lot faster and we can utilize these services better, when we do it in the cloud, we're optimizing the cost as well, which is a big thing when we're doing stuff on the cloud. With ETL, we don't have this flexibility. And basically, the ETL process is used more for on-premise analysis, unlike DLT, which is a lot more adapted to today's cloud texture. So when we design either ETL or ELT pipelines, we have like this data pipeline, and we usually start with data integration. So the data integrations is basically having connectors to the source data and also having connectors for the destination. So basically, when we try to write a script, we will have to maintain these connections. We have to write this script in such a maintainable way that we can easily add new sources and new destinations. As on this note, also the transformation. If it's an ETL process, then we have to write a special scripts that are heavily optimized for handling that transformation on premise. If it's on the cloud, yes, we still have to write very maintainable code as well, but it's a lot easier from performances aspect since the transformations can be done on very powerful services. Next, we have the orchestration, versioning, and monitoring, which are very crucial to writing a data pipeline. So the orchestration is basically when we will run this pipeline, on which schedule, monthly, daily, and this has to be maintained as well. As for the versioning, we have like multiple versions of that pipeline process. So some older pipeline has for example, reading from only a database. The next version is only reading from a database and some API. So we need to have versioning as well and switch between these versions a lot easier if we want to deploy it to some server. Same goes for the monitoring. So we need to have a very good tool for monitoring these pipelines, so either getting the logs in one place and also checking if this pipeline fails or not. And a lot of these points above that I mentioned are part of this customization, which goes back at the roots again because we always try to change this pipeline. So we always add new sources, we always add new transformations. We're going back and forward in this pipeline all the time. And over time, this gets a lot harder to maintain. So this is where actually Meltano comes to the rescue. So basically, this is an open source CLI framework, command line interface framework, managing ELT pipelines, and is developed with DataOps in mind. So DataOps basically handles the versioning and the monitoring very well in order to have these pipelines easily maintained. Momentarily, the scheduling is with Airflow and Dexter, so Airflow has a lot tighter integration. Dexter is pretty new, and also also one of the main points of Meltano is that we have replication methods. This is managing a state. So when we usually do either ETL or ELT, we need to do a certain type of loading of the data. So loading of the data can either be full data load, where we actually pull the whole data, or we can do incremental data pull each time when we run this pipeline. And this is this is very easily maintained with Meltano. So on this slide over here, basically, I will just give an intro what we will see in the demo, and some of the nomenclature about what is used in Meltano. So tabs are basically the sources. They are packages mainly written in Python, and they can use for extracting data. Target is the destination where we want to save the data, but there are also packages that can be easily installed. And in utilities, we have all other tools that are crucial for scheduling, transformation, monitoring, and that can help us to easily maintain our pipelines. And now what is really good about it is that all of these packages, they follow the so-called Singer spec. So this is a standard that is not very long ago defined, and it's mainly used to have a unification about how we write ELT pipelines, and it helps us about writing a maintainable and easily reproducible code. So I will start with the demo. So at first, it's a lot easier since Meltano is very easily installable in Python. I recommend that when you want to use this tool, it's good to have Anaconda installed for managing packages, and we can install it there. So I can run it from here and in terminal. So we can just install the package with pip install Meltano, and this will install the package, and it will be ready to use for anything that we want to create as a pipeline tomorrow. So I would just activate the environment in Anaconda that has Meltano. Very crucial note about Meltano is that it mainly works with Linux-based environments. So if you have Linux, great. If you have Windows, not great. You will need to have Windows subsystem for Linux installed on Windows, basically. And for the Mac OS, I think it will run natively or will run very good. I haven't tried out, but since it has like Unix background, it should run okay. So let's create a demo project. So we do that by writing Meltano init, and we specify over here the name of our project, which will be also the name of our folder. So I will call it lab demo Meltano in this case. and this will create a whole new folder with a project inside. So when we go inside this folder, IT Labs, Demo Tunnel, we can also see in the folder east side that we have several folders and also several files. So I will not go through the folders a lot in detail. What is most important here to follow is that we have this YAML file, which is crucial about how we orchestrate our pipelines. And also we have this requirements txt. So for those that are coming from Python, this requirements txt is used to reproduce the packages that we have installed on our system. So later on that we can install this file, so the packages from this file, and we can run these pipelines locally. So on this side over here, if we want to add a source, for example, we write the command Meltano, just increase my screen over here. Meltano add, and we specify, do we want to add the extractor which pulls the data, or we want to add a loader where we save the data, or some other type of tool. So we will add extractor, which is called tab CSV. So we will read basically data from CSV files, and this extractor will be added to the Meltano YAML file. Just installing at this moment. Okay, it's installed. So if we open the Meltano YAML file, we have these plugins, which can be everything as I mentioned before: extractors, loaders, or schedulers. And we have like some metadata here about the installed package. Okay, so we have this source installed. So we're gonna read CSV files, and later on we will save these files in JSON format. But in general, you can read from any type of source, and you can save it to any type of destination. I will come back to that a little bit later on. But for now, we're gonna add a destination, which is called tab JSON line, and this will install the connector. Okay, discover loader. So tab JSON. Oh, my mistake. It's not tab, it's target JSON lines. Tabs is basically a prefix that is used for all of the sources. Target is basically used as a prefix for all of the destinations. So we have that installed, and now we want to check what do we need to configure for reading these CSV files. So the CSV files, I have them in the other folder. So they are in this data folder over here. I'll copy paste them. I will add them here. So they are CSV files. One is user data, which has name, first name, last name, emails, and some basic user data. The transaction data is basically data that we have, like the value of the transaction. Also, IP address is basically emulates an online transaction, and they're all stored in CSV file. So we want to usually all of these extractors, loaders, whatever, they have certain configurations that we need, certain configurations and variables that we need to provide. So when, for example, if we added a extractor tab Postgres database, when we install this extractor, we will need to configure the host, username, password, so we can access the data from this database. So we want to add a configuration for the CSV extractor. So we will do that by typing Meltano invoke, actually not invoke, config tab CSV. So we want to set configurations and we want to do them in an interactive way. Some of these packages have this interactive option, some of them not. This means that by this CLI user interface that we have over here, we can add them interactively. The other ones that they don't have, we can just either add it manually by either changing the configurations in the Meltano YAML file or just adding some different sort of file that can be read later on from this package. So what we need to provide is this third one. So it has array of objects with entity path and keys. I will add a third option. And the third option is basically a object with entity path and keys. So entity is the entity name used as table name. So basically this is how we're gonna call the table or one of the sources that we pull data from. So entity, this will be users. The next one is path. So this is the path to the file, basically. We will have path, which is in the data folder. It's called users data.csv. And we have keys that is basically the columns that are the unique keys in that data set. So keys, the primary column is, I think I need to pass this in a list. Yes, the names of the columns. So in a list, they are named ID, so it's not very hard to follow. And now we need to add, because we have two files, user data and transaction data. We will do this the same for the transaction data set as well. So we have transactions. We have path, which is the path to the file. Data slash transaction. Oops, I'm overwriting something. What am I overwriting? Oops. What am I overwriting over here? Nothing, actually. Transactions data. I think I called it like that. I will check. Transaction data. And this is also a user data. Transaction data.csv. And we needed to provide keys, the list, which are the primary keys. This is ID. And this should work. Yes, great. Tab, pressing to continue. Okay, we're gonna exit this. And now we will run this pipeline as a demo just to see. So to run the pipeline, we do Meltano run, tab, CSV, target, lines. And what we'll basically do is just connect these packages and it will run them in a background. And it will run them basically in an efficient way because every time a single data is coming through one of the sources, it's immediately written on the destination system. And as we see, we have, the pipeline completed successfully. So the data is saved and output locally, and we have these JSON line files over here that basically are the data that we read from the CSV files over here. Great. So this pipeline passed. That's awesome. Now, if we want to add a orchestration over here, so actually scheduling the pipeline, we need to install orchestrator, which is Airflow. Orchestrate, actually add, not install. Add orchestrator. Airflow. This should install like all the necessary packages that we need for scheduling a pipeline. So a little bit, yeah. Little note over here, the default that I have set up, it's not working from the start. So the quick fix around this is just changing this version over here. So from 2.1.2, just change it to 2.3.2 as well over here. And if we do Meltano install this time, so Meltano install orchestrator Airflow, this should pass. Okay, installing orchestrator Airflow. Anytime soon. Since it's taking this long time, apparently it's gonna be a successful one. Yes. So we have installed Airflow, and basically we want to schedule jobs. So we do it by Meltano. I have to check the documentation for this again. Not this. So we have, oops. On documentation, we have to orchestrate data. So basically what we'll do is first defining a job. So we will define a job Meltano at job, I think. Job at, okay. Job at the name of the job, so CSV to JSON line. And we will have tasks that are basically the packages that are going to be used for this scheduling. Okay, move. So tasks is tab CSV target JSON. This should work. Yes, perfect. And we have added this job, and for actually scheduling this job as well, we will add Meltano schedule at, which is the job that we created from before. So it was called CSV to JSON line, and we added, actually no, it's a different name, but we can add like schedule, and then we add the job, which is CSV to JSON lines, and we set the interval of how often this job should run. This moment will be, again, let's set it up at daily. We can have like daily, monthly, and this also accepts the so-called cron expression, which we can schedule this job at random intervals. Let's add daily for simplicity. And we have this job scheduled at a daily level. So if we open the Meltano YAML again, we will have all of this information over here. And if we don't like something, we can either manually change it or we can change it by the command line. And one final tool that I want to show is to add a, so we can have this pipeline run locally, but we also need to reproduce this pipeline on some server as well. So Meltano has this option to create a Docker file for us. that we can easily later on distribute it to another system and build this Docker file and run our pipelines on that system. Meltano add files, Docker file, I think it was called. In the meantime, if this doesn't pass, yeah, it didn't pass. Let me go to the documentation. Meltano, we have product, we have the Meltano hub. So on this Meltano hub, you can see all of the available connectors. And as I was saying before, you can actually write your own type of connector to either get data or store data. That is done with a single spec, and it allows us to be compatible with the Meltano ecosystem. So we have files for the Docker image. Here's Docker, and we have Meltano add file, files Docker. So file Docker. So this will create a basic Docker file. Okay, it won't create a basic Docker file. File Docker. Now it should create the yes. Now it should create this Docker file. And here it is. And this basically has a simple Docker file here, but we can modify it to our needs and basically redistribute it to any system or server that we want to run this pipeline. Great. So yes, that is for the demo. Go back. Oh, that is the end. So are there any questions? Sure. So Meltano, if you're starting to learn Meltano for the first time, I'm gonna be honest, it has a little bit of steep learning curve, so it's not really easy to grasp at the beginning. But as time goes by, if you kind of get along with it, you will realize how everything is connecting. And when you get the, so to say, the feel for it, the development of these pipelines is at a very fast rate. So you can develop these pipelines very fast and redeploy them in any system that you like. So usually, Meltano is like one piece of the puzzle that is done. We have like integrations, like continuous development integrations that helps us to distribute these pipelines somewhere. And if we have also that set up with Meltano and its utilities, we can actually set up pipelines very fast. The only drawback is that if the person is starting for the first time, it takes time to grasp the whole concept of it. But after that, every single development of a pipeline is pretty fast. Okay. So in the Q&A, we have, what is the benefit for using Meltano in comparison to ADF, for example? So I haven't heard of ADF before. I cannot actually give really good comparison on this one. Azure Data Factory with pipelines. Okay, great, thank you. So the main benefit is that when we do with Data Factory, we will have to write the scripts for connecting to certain sources, and we will have to write them in very maintainable way. So basically, these scripts have to be written so well that can be compatible with anything else that we add tomorrow as a source, but also as a destination. And these scripts can change over time. So basically, if we run just basic pipelines, read from this database or read from this file, for example, in Azure, if we read it from a blob storage or from a database that is from Azure, these connectors in data pipelines are very easy to implement. But if we need some really complex, like reading from APIs, for example, data pipelines will not be very suited for this case because we will need to write a more custom scripts. For example, if we use as well data factory that is available on Azure, we can write a Databricks scripts that can read um, from the certain sources, and then we can integrate these scripts in the data pipeline. So maintaining the scripts will be very hard later on, and also even if we write them, we don't have the capability to uh, easily monitor about what happens to the pipelines. I mean, yes, we can see that it fails, but we have to integrate the logging very well, so we can see the exact reason why a certain pipeline failed. And with Meltano, this is very easy. The Meltano have this UI option, so they have their own user face. Now, a slight note on that, with the latest versions and the latest version that are coming by later on, they try to deprecate the user interface for some unknown reason. For anyone that wants to try it and run it in production, the version that is compatible is like 2.72, and it will work with everything from authentication to running all of the pipelines smoothly by the user interface. So I hope that answers your question. Yes, so the user face that we saw right now is not the actual user face. So there is a command called Meltano UI, which will create a web application in the background. So it creates a web service where we can easily run the pipelines manually. We can schedule the pipelines also from there, and we can check also if the pipelines failed or succeeded, and also the logs from a given pipeline. And it gives us also the flexibility also if we need authentication. So the authentication is very easily managed. So that is very easy to get from the UI itself. The command lines over here basically added to a Docker image where we just deploy this and we just run the same commands in the Docker image when we try to run it. But the Meltano UI is the one that we can actually have a full overview about what is happening with the pipeline. Yes? Yes, I have. Now, as I mentioned, with this version, because I have the latest version installed, the Meltano UI might not work as it said it will get deprecated. So if I go on this address over here, open link, we'll have this tab like extractors, loaders, and pipelines. And basically in the extractors, now this UI won't work because of their latest version. That's why I said the correct version of that. But in the extractors, we will have all of the sources listed. In the loaders, all of the destinations listed, and the pipelines, we will have the actual pipeline itself. So we will have the ability in this pipelines tab to reschedule a pipeline and check its status if it's failed or succeed, and also the logs from that pipeline. Okay. Are there any other questions offline, online? Okay, so my project Meltano is used for basically transferring financial data and is used for transferring this data from multiple sources. At my case, these sources are APIs, which we don't have a already made connector. So everything that is made was custom made. and it helps us to write as many connectors as we want to many different sources. So they have like internal APIs that we want to pull data from, but also a publicly available ones that don't have predefined connectors, but they can be easily written and easily afterward integrated in this pipeline. And when we have all of these pipelines integrated by the Docker file, we just deploy this Docker file, in our case, at AWS, and we call these pipelines on a certain schedule, and it's basically running autonomously and on the background. Yes. So basically Airflow is used for scheduling of the pipelines. So when I added a extractor Airflow before, despite adding it to the Meltano YAML file, which is here, okay, it doesn't work. Here also adds a predefined file. It's a Python file that it will run these scripts in the background on scheduled intervals. So this can be found in orchestrate, DAX, and Meltano.py. So this is already written file and is used in the background by Meltano to run these pipelines at a scheduled interval. So basically we don't write any Airflow related code. We can change this file if we want, if it doesn't meet our use case, but most of the time it will satisfy our case. Thank you everyone for your time, for listening this presentation. I hope it was interesting, and I hope you will use this framework for your data workflows one day.